All right, we are doing volume applications, and what we're going to do first is we're going to draw a rectangle that represents a sheet of paper. Do any of you guys know what the dimensions of a sheet of printer paper are? It's close, it's 8.5 by 11, so 8.5 by 11. Okay. So we have a sheet of paper, it's 8.5 by 11, and what we're going to do, this is a very common type of problem for Math 3. They like to do this a lot. They say, if you were to take a piece of paper and you fold the sides and fold the side, or sorry, not yet, cut out corners like this. See that? I cut out a corner, I cut out a corner, I cut out a corner, and I cut out a corner, and I cut out the corners so that they are squares. You guys see that? That the side lengths of the corners look like they're about the same. What I did is I cut out a corner. We're going to go ahead and draw them. I cut out a corner that was 1.5 inches. And I cut out this corner, it was 1.5 inches. And I cut out that corner, and it was 1.5 inches. And I cut out this corner, and it was 1.5 inches. And what they say that you can do when you cut out those corners is then you can fold. We can fold this, and we can fold this, we can fold this. And if I was to tape the sides together, I would have a little box without a lid. You guys see that? Yeah, here's my box. Okay. Does that make sense? Okay. So if the original paper was 8 inches long, and I cut off 1.5 and I folded it up, and I cut off 1.5 and I folded it up, what is the new length? 5, because we do 8 minus 1.5 minus 1.5, and that gives us 5 inches for the width. Okay, so I'm going to say that I'm going to make this a different color. Over here. Oh, 5.5. Sorry, you're right. You're right. You're right. That's right. I said 8 instead of 8.5. So, and it would have been the width. The original width was 8.5, I cut off 1.5 inches, I cut off 1.5 inches. The new width is 5.5, okay? If the original length was 11, and I cut off 1.5 and I cut off 1.5, 8 is the new width, or length, sorry. I get those words mixed up a lot, can you tell? Okay. So I would say that if I wanted to know the volume of the box, I would do the length of the box times the width of the box times the height of the box, right, to find the volume of the box. So if I think of this box that I made right here, we said my length is 8, my width is 5.5. Can you guys tell what the height would be? 1.5, right? Because we cut out that corner and then we fold up those sides. The height is 1.5. Yes. Yes, but I'm setting you guys up so you can understand. Yeah. So the length is 8. Sorry. The width is 5.5. The height is 1.5. Okay. So go ahead and multiply those on your calculator. Let's figure out what the volume of our box would be. Someone other than David. Thank you, David. Oh, poor David. 66 inches cubed. Okay. All right, let's try it again. Let's try a different sheet of paper this time. We're going to say this sheet of paper is 11 inches by 6 inches. It's a smaller piece of paper, and this time I'm going to cut out corners that are 2 inches. 2 inches, 2 inches, 2 inches, 2 inches. So 6 by 11 for the original sheet of paper. And I'm cutting out 2 inches on each side. So if my original width is 6, and I cut off 2 and I cut off 2, it'd be 2, yeah. That's a really tiny width, right? And if my original length was 11 and I cut off 2 and I cut off 2, it'd be 7. Okay. So if I wanted to find the volume of that box, I would say the volume is length times width. And do you know what the height would be? 2, because I cut off corners that were 2. And when I fold up those sides, they're going to make a height of 2. Okay, so what would the volume of that box be? Yes. 28. So 7 times 4 is 28. 28 inches cubed. Okay. All right, let's go ahead and flip to the other side now. So it says we have a box with a rectangular base. It's made from a piece of cardboard, and the cardboard is 18 inches by 28 inches. So 18 inches by 28 inches. And this time they say they cut out squares and they don't tell you what the dimensions of the squares are. So we don't know if it's 1.5 by 1.5 or if it's 2 by 2 or if it's something else. So I'm going to go ahead and write this. I'm going to say x and x, x and x, x and x, x and x. Okay, so my original width was 18. What's my new width? 18 minus x would be 18 minus 2x. Does that make sense? Okay. 18 minus 2x. Okay. And the original length was 28. And then we cut the corner, folded up the sides. So that would be 28 minus 2x. Okay. So I'm going to say my length is 28 minus 2x. My width is 18 minus 2x, and then what would the height of the box be? Not 2x, x, because it's the x side folded up and the x side folded up. Okay. Now it says to write the volume of the box, and we're going to use the length, the width, and the height, and we're going to multiply them together, but we don't have to FOIL it because this is a calculator active question. Okay, so for length, I'm going to write 28 minus 2x. For width, I'm going to write 18 minus 2x. And for height, I'm going to write x, and then I'm done. I can leave it just like that, no multiplying. Isn't that nice? Yeah. Okay. So before I move on too much, I'm going to write down what x represented in the original problem because that helps us answer some of the questions later on. Okay. So when we originally started the problem, we labeled these as x, and what were we talking about? The side lengths of a square that we cut out, right? Okay, so I'm going to say x is the side lengths of the square that we cut out. Go ahead and keep writing it. Okay, so side lengths of the square that is cut. Okay, so we're going to go ahead and graph this. So we're going to type 28 minus 2x and 18 minus 2x and x. So I'm typing it in exactly the way it looked on my paper. And a window that's normal, negative 10 to 10, is probably not going to work on these story problems. So what I'm going to do is I'm going to hit second graph, and I'm going to look at the y coordinates that correspond to reasonable x coordinates. For example, I cannot plug in 100 for x because you can't have a 100 by 100 square cut out of a 28-inch sheet of paper, right? That answer doesn't make any sense. So what are some other x values that do make sense? And what are some x values that are like too big or too small and they wouldn't make sense? Yeah, anything above 19 would be kind of weird, right? Because one of the sides of the paper is 18, so anything bigger than that. In fact, anything bigger than 9 wouldn't make sense because we're cutting it from either side. Okay, so if we look at this, I can see that the biggest number is 800. Do you guys see that? The biggest number is 800. So I'm going to go to my window. X values from negative 10 to 10 are great because that 800 value happened at 4. And any bigger than that looks like we're good. So what I'm going to do with my window is I'm going to take my y max and I'm going to make it maybe like 1,000 because that's bigger than 800. You could do 900, you could do 850. I just would do something bigger than 800, okay? I do not like it when my x-axis is on the very bottom of my screen, which is going to happen if I have a -10. I'll show you. See how it's at the very bottom of the screen? I don't like that. It makes me feel claustrophobic. I don't know why. And so I'm going to hit the window button again. I'm going to change this to like -200 just because it makes me feel better, not because you have to. Okay? I just feel better about it. Okay. So there's our graph. Now it says, what is the volume if a 3-inch square is cut out? So when they say a 3-inch square is cut out, they're telling us x equals 3. How can I use the calculator to plug in any number I want? Second trace, do the value. Now that would plug in anything you want for y. We want to plug this in for x. So second trace number 1, I'm going to plug in an x value of 3. 792. So I'm going to say v of 3 equals 792. And then my favorite part, story problems get story answers. If a 3-inch square is cut out, the volume is, or the volume of the box is 792 inches cubed. Making sure I have my units. All right, what am I plugging in next? 8. Okay, so I'm going to say v of 8. Just plug in 8. Is 192. 192. Okay, so if an 8-inch square is cut out, the volume of the box is 192 inches cubed. Okay, before we even do the math, would a 10-inch square make sense? No, because it's above 9. Okay, let's do it anyway and see what happens. Plug in 10. So if we cut out a 10-inch square, what's the volume of our box? Negative 160. Does that make sense? Okay, so what is the volume if a 10-inch square is cut out? Does this make sense? No, it cannot happen. Cannot happen. I erased have and wrote have again. It cannot happen because the rectangular sheet is not big enough. Does that make sense? And a negative volume is not possible. Okay. Now it says, where is the volume the largest? So if you look at the graph, where do you think the volume is the largest? At the maximum, right? That's the biggest y coordinate, so we're going to go ahead and find the max. So I'm going to look for maximum. I'm going to do my left bound. I didn't know where my cursor was. I'm going to look for my cursor. There it is. I'm going to do my left bound and my right bound. You guys know I'm not going to show you this answer. I don't hear any clicking. You just don't hit your buttons hard? Okay. All right, so the max Go ahead and tell me what the x value and the y value are, and then we'll figure out how to interpret our results, okay? So what are you guys getting for the x coordinate? It is a decimal. 571, okay. And then what'd you guys get for the y coordinate? Okay, don't clear that. Leave that on your screen. Okay, everyone see that? You ready? You ready? I'm going to teach you how to do something with your calculator. Okay. Here's what I want to see next. Second quit. Everyone type that. Second quit. The mode button. Second quit. And then see the X button right underneath that? Hit the X button and press enter. What did it do? It took the X value and it pulled it from the graph and it made it so you can use it. Does that make sense? Okay. Yeah, it's cool, huh? All right, so leave that on your screen. We're going to start answering these questions, okay? You guys ready? All right. It says, for what value of X is the volume the largest? What are the dimensions of the box with the largest volume, and what is the largest volume? Okay, so what does it mean when it says what are the dimensions? Length, width, height. Okay, so now, because you have that x stored in there with those decimals, now you can just type in 28 minus 2x, because that's the length. Mind blown. 18 minus 2x. And the best part of this is you are getting exact answers. These are not rounded decimals. Like, you're going to round it when you write it down, but it pulled that perfect number from the graph. Yeah. All right, so our dimensions are 20.859 by 10.859 by x, which was 3.571. Okay? So the length, I'm going to go ahead and write it down. The length is the 20.859. The width is 10.859. The height was just plain x, which was 3.571. And then the overall volume of the box is 808.746, and we should have inches, 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 and then inches cubed. Technically, we should have written a sentence, but we're close to the end of the period.